So how to factor a quadratic with a leading coefficient of 1, meaning the number before x squared is a 1. And of course factoring means we're going to take some sort of quadratic and rewrite it as a product of two or more things. So it's important to remember that we can see if we use the distributive property here, if I were to distribute the x times the x, that gives me an x squared. Now if I distribute that x to the 1, I get a 1x. If I distribute this 2 to the x, I get a 2x. And then at the end, we're going to do 2 times 1, and that's going to give us 2. So collecting like terms, we get x squared plus 3x plus 2. Now this illuminates our method for factoring a quadratic when the leading coefficient is 1, is we can see that the numbers that we used in our factors, 2 and 1, they add together to be 3, which is the b value, and they multiplied together to be 2, which is the c value. So we know that we can use our sum product table. We want to find numbers that would multiply to a certain product and then add to a certain sum. So if we were to try to do it here, what numbers would multiply to be 2 and add to be 3? Well, that's why we got the numbers positive 2 and positive 1. And those are the numbers that we included in our factoring. So in this example, we're going to factor 2 at the same time, so we can see here that on this example, our c value is positive. Now, c value is going to be our product. So in both of these cases, we are looking for two numbers that would multiply to 12, because 12 is our c value. Now when we multiply two numbers to be positive, we have two options. We either have a positive times a positive, which would give us a positive product, or we have a negative times a negative, which would still give us a positive product. So we can use some context clues. So on this side over here, since our b value is a positive number, we know that we must have started with two positives, because when we multiply two positives, we get a positive. When we add two positives, we get a positive. So what two positive numbers multiply to be 12 and add to be 7? Well, that of course is going to be positive 3 and positive 4, which would then factor as x plus 3 and x plus 4. Now over here, since our b value is negative, I know that we're trying to add to a negative 7. So if they multiply to be positive but add to be negative, it must have been two negative numbers. And that's where we use negative 3 and negative 4 to inform our factoring of x minus 3 and x minus 4. Now in these examples, we can see that we're trying to factor two quadratics, but we see that our c value is negative. So our c value here is negative 5. So in both of these examples, we're going to be looking for numbers that multiply to be negative 5. Now the difference in these examples that we can see is that their b values are different. On the left side here, I want those b values to add to negative 4, and on the right side, I want those b values to add to positive 4. Now if I'm multiplying two numbers to be a negative, it's either a negative and a positive, or it could be a positive and a negative. What we see is that their signs have to be different. So when I'm thinking about multiplying to negative 5, I know the numbers that I'm interested in are 1 and 5. On the left side here, I know that those numbers are going to combine to be negative. So if I have a group of 1s and a group of 5s, and I want to add them together to have a result of a negative 4, that means I needed to start with more negatives. So the bigger number would have been negative. So my factors would have been negative 5 and positive 1. Now on the right side here, I know that my factors of 5 are going to be 1 and 5. But if I want to combine a 1 and a 5 so that I get a positive number at the end, that means I would have been combining more positives than negatives. So the smaller number would have been negative. So that informs me that I wanted to use positive 5 and negative 1.